description of this video. So now we are on video 7 of this series, and we're going to look at how to wire up a temperature sensor. We have the code 7_temperature.py, which we'll go through in a bit of detail. So this is the wiring diagram. It's a little bit fiddly. You may take you a few attempts to get it completely right. Luckily the code works and is stable, so that if the code isn't functioning, you've probably wired it wrong. There are two components, the temperature sensor itself and the resistor. Because there are 3 pins on the temperature sensor, there's quite a bit of wiring to make sure everything goes to the right ground, power line and up to the GPIO on the Raspberry Pi. We're going to introduce a few concepts which you'll see in the code, math operators and how we add and multiply numbers together. We're going to introduce the concept of one wire, which is related to the temperature sensor. So this is the code in its entirety. Unfortunately, I've tried to explain every line in a video and it went on to about 25 minutes long, and that's too long for a video. So unfortunately, we're not going to learn a lot of new concepts in this video. You can pick through the code on your own. Unfortunately, I would like to explain it, but like I say, it will take too long. So we're just going to look at the code from a very high level. So the first 2 lines of the code here we have, which call to the operating system, run the command modprobe 1wire GPIO, 1wire therm, which is the thermometer or the temperature sensor. And by issuing the command, you are able to interface with the 1wire sensor. So without that, you actually can't take a reading from the sensor. The next 3 lines, what they essentially do is they look into a directory, which is sysbus w1/devices, and then what it does in there, it looks for a file, and in there will be a raw reading or raw output from the thermometer to a text file, and then the rest of the code reads that in. The function, this one here, is called read temperature raw. Basically it just fetches the information that's been written to that file earlier on, and it saves that to memory. So this second function, what it essentially does is it will read in that information from that variable in the function above, and what it will basically do is it will keep checking in case there are any errors, because the thermometer can throw up a few errors from time to time. It will keep trying until it finds its successful entry. And then what it does, the function returns 2 values, the first being the temperature in degrees Celsius and then in degrees Fahrenheit. Then at the bottom here we have the main loop of the program that simply loops and reading the temperatures, and then it prints that to the screen, and then it waits for a second and then prints it again. So let's see how that works in the real world after wiring up. If you want to learn more about programming and Python in particular, head over to Code Academy and follow their Python track. They've got a fantastic interactive website that can teach you far more than I can in these small videos. So this is the actual thermometer. It is a DS18B20 and there are 3 pins on it. The one on the far right is the pin 1, which is the ground that goes to your ground rail. The one on the far left is the power rail, power pin, that's pin 3, and the middle pin is the one that actually has the data, which sends the information of the reading from the chip, the actual temperature, to the GPIO header. So here comes the fiddly bit. So get your thermometer and connect it up. There we go. It actually doesn't have any relationship to the buzzer there, even though it looks like it does. So we're going to connect our resistor to pin 2, which is the data pin, and we'll come back to that in a minute. Let's put that directly close up against the thermometer to make it nice and easy. Then we're going to connect up pin 1, which is on the far right, to the positive rail, the red line. Then we're going to get another cable, which is going to go from our pin 1, our negative rail, and we're going to connect that up to the negative rail. Here we go. Again, it's quite fiddly, it's quite small here. Okay, it goes to our positive rail. And we need another cable that's going to go from the resistor to the positive rail, and then the last one is going to go from the data pin, pin 2, up to the GPIO. There we go, that's it wired up. Unlike the rest of the code, because we're using the 1 wire interface, it's a bit more complicated. We have to set up a few things before we can use it. So we need to change into, we need to run the command sudo mod probe 1y or w1 dash GPIO, and again we're going to run sudo mod probe space 1w dash therm. Now this is actually, these two lines are actually in the code as it was explained earlier. We're going to do this manually so we can make sure that the electronics is working. So we can change into the directory sysbus 1wire slash device, and we're going to check and see if the device has actually been picked up. If it has, when we run ls-l, you will see a serial number of the chip there. If you don't get a directory that looks like that, then it's not working. If we then run the command cd into that serial number, which is the directory, and then we look inside that directory and cat for a file called 1wire or w1 slave, you will see two raw readings from the thermometer. They are the two lines that get converted into Celsius and Fahrenheit in our code. So let's change into our directory where our code is kept, which is /home/pi/desktop/GPIO underscore Python code. Find our temperature code and run sudo python 7 underscore temperature.py, and there you'll see the code in action, one by one, reading the temperature sensor to the screen. And there we go. If you see I put my finger on it, the temperature will go up slowly, and then when I take my finger off in a minute, it will go down. They're not perfectly in sync because the videos record at different times, but that's basically the process. So if you want to keep